Okay, for this one, we have to see if this function satisfies the first three hypotheses of Rolle's theorem, and then find some number c that satisfies the conclusion. For Rolle's theorem, all it says is if you have some function that has equal y values as starting points, and it's continuous and differentiable, so it can look like that, it can look like that, it can just look like a straight line, anything like that. As long as it's continuous and differentiable, then there has to be some number c. For instance, on this line, c would be right there. For this straight line, c would be everywhere along the line. And for this lower line, c would be like about right here. But anyways, it's in these positions because that is where the tangent lines are horizontal or the derivative equals 0. That means the same thing. So to figure out where the tangent equals 0 or slope equals 0, we have to take the derivative of this. So using the derivative, we're going to be using the power rule for a lot of this. Power rule, all it means is you take the exponent times the exponent by the forward value. So in this case, 2x squared would be 4x. Once you take it down, then you're left with a 1 there because you minus 1 away. So 4x to the 1 is the same as 4x. Minus, same thing here. So we have x to the first, so it would be 1 times 20, which is 20. Drop that down to 0. Any number to the 0 power is equal to 1. So you just have negative 20 here. And then any constant is just 0. So plus 0. Okay, so this is the derivative. We're going to mark it like that. And then we're setting the derivative equal to 0. So 4x minus 20 is equal to 0. 4x equals 20. Solve for x, divide by 4. X is equal to 5. Okay, now that we found out what x equals, we have to double check that it is in our interval. And it is, so it satisfies the conclusion, so that's going to be our answer.